Hello everyone, my name is Hui.
I'm Zain Solis.
Okay, we are part of a Team 6 from the University of Houston Electrical Engineering Department. We're senior students graduating this semester. And for our senior design, we work on what is called a wearable device to measure attentiveness of a person. The project was proposed by Dr. Rose Fagi, a professor that we worked with for a research project for one semester. And so she proposed this project as an extension from research to real life application. and so the project entails that using skin conductance, we would like to measure attentiveness of a person. And we kind of gear this project to our specific application, more specifically oil and gas manufacturing industry, more kind of long hours working, assembly line, where attentiveness could be crucial in preventing fatal accident as a person is losing attentive and they get themselves caught in a fatal accident. Okay, maybe Zane can go a little bit about our own design.
So over the past few months, we've been speaking to customers out in various different industries, and we found that, let's take a few steps back. So skin conductance that relates to someone's attentiveness can be measured from two places that we found. We found this during research. This could be from the hand or it could be from the bottom of the foot. After speaking with people from the industry, they found that anything that you put on the hand area could potentially become a hazard because it could be a place where it could be machinery could get hung up on it, or you could touch some wires or something along those lines. So they asked to put it somewhere else. So we decided to go with a type of sock design, as you see here. So we have one skin conductance sensor, and it's embedded on the bottom of the sock, and we have our electronics housed on the cap of the sock. Okay. So I guess we can go into.
So with this design, the sock is designed to collect data continuously in real time and then send that data via Bluetooth to a phone application where some algorithm has been coded into the app to process data to kind of translate that information into more a direct, whether the person is attentive or not attentive condition. So here behind us, we have a typical skin conductance data with its specific shape. So skin conductance has a very own specific shape, as you can see here, these spikes, which is what we call here by an exponential function, where you have a very sharp rise time and very slower decay time. So these are specific to skin conductance. Now we can see that when we have these spikes is when the person is more focused, is more attentive to speak neural task, versus here is this more slowly changing signal where the person is not attentive and the signal is not changing at all.
So we can give a live demonstration. This design goes on the foot. If you want to move the thing kind of down. You see it down here? And the sensors will be on the bottom of my foot. Okay. Now we have our phone application.
We can press clear for a new section, data.
And so as I'm wearing the module, you can see the skin conductance is starting to increase. Okay, and initially in the top right corner, you can see that it's calibrating, and eventually after amount of time, maybe like 50 seconds, it'll tell us whether the user is attentive or not. Let's see. currently, since this is the first set and you were just putting it on, it reads not attentive. But within the next 50 seconds, it should update.
We should just do non-attentive. Since you put it on, doing nothing.
There it goes. So there, we see we are attentive. And if I were to take it the module off, of course there's going to be close to zero skin conductance. After maybe another 50 seconds to 2 minutes, it should update and say that the person is non-attentive. Not attentive now. So how it's going to count is our circuitry. This is what it is. So coming from these two wires, we have two Deutsch connectors connecting to our sensors that go to this amplifying board. It's going to amplify that voltage signal, and it's going to be fed into our LilyPad Bluetooth module. And this is a unique Bluetooth module because it also has a microcontroller built inside, and it has 8-bit resolution, and it's converting our analog signal to a digital signal. And this is where we run a small algorithm that converts that voltage to skin resistance, and then we do 1 over that to give us our conductance, and we multiply that by 10 to the negative 6, which gives us microsiemens, which is typically what skin conductance is measured in. Further down here, we have our power supply that's going to power our board and our sensors, and also a charging module. So whenever this battery runs low, we can charge via micro USB our battery.